Hi guys. I'm going to do my best today to help you work through one of the PhET labs. So what I want you to do is to make sure that you have the paper copy of this lab from the front desk first. Okay. So make sure that you have that. And then once you do, I'll go through these directions with you. Okay. So this talks about logging in, going to simulations, picking molecule shapes. All of that, you can just use the link that I posted for you. So I posted the link to go right there. But when you open it, you're going to click the one that says model, and then you're going to check the boxes for molecule geometry and electron geometry. Okay, so when you go to the lab, it'll look like this. You're going to click on model, and then down here in the bottom corner, you're going to check molecule geometry and electron geometry. Okay? All right. So your task is going to be to build molecules with varying domains. So a domain are the electrons that are attached to the central atom. So those are the spots that are able to be bonded. So even the lone pairs are a domain. So if you remember when we talked about a tetrahedral, we said that a tetrahedral had 4 spots that could bond. So those 4 spots are what we call domains. And then we said that a pyramidal started off like a tetrahedral, so it had 4 domains, but it had 1 lone pair. Okay, so the domains are the possible number of electrons that could bond, and then how many there are that are unshared. And then we had bent, that we said had a possible of 4 ways to bond, but had 2 lone pairs. Okay, so this is what we're talking about. So domains are the possible things that can bond. So if you notice down here in the table, we're talking about the number of domains, the possible bonds. Then what we're going to look at is this difference between molecule geometry and electron geometry. So its molecular geometry is going to be different than its electron geometry. The electron geometry is going to have to do with how many are there or not there. Okay, so I'll go through a couple of them with you. And what you're going to do is record what the electron geometry is and the molecule geometry, and then make a sketch of what the shape looks like. And you'll see that in this, the molecules are 3-dimensional. So you'll actually get an idea better of what tetrahedral really looks like. So you might want to rotate the molecule to see what it looks like. Okay. All right. So the first one says total domains is 1. So meaning there's going to be 1 thing bonded, 1 bond, no unshared pairs or no lone pairs. Okay. So I'm going to go back up to here. I'm going to take off one of these. So I'm going to check this X up here. Okay, so now I can rotate that around and see what it looks like. Okay, so I have my central atom, which is the purple one, and it has 1 domain, 1 bond on the center atom. There aren't any unshared pairs. So then if I look down here in the corner, I can see that my electron geometry is linear and my molecular geometry is linear. And then I can pretty easily draw a sketch. Okay. So in your notes then, you'll have linear for the electron, linear for the molecular geometry, and then to sketch it, I had my central atom bonded to the other atom. Okay. Now, something that I'd like you to do that the directions just up at the top don't necessarily say is if you go back here and you click here on show bond angle. Oh no, it won't show on this one. Okay, sorry, I don't want you to do that. Okay. All right, so now the next one in our table says 2 domains, so 2 things around it, with 2 bonds on the central atom, no unshared pairs. Okay, so I'm going to go back here. Purple's the center one. So I want to have 2 bonds on the central atom. So I'm going to drag one of those in. So I can spin this around and see what it looks like. Okay. So right now it has 2 bonds on the center atom. There aren't any lone pairs. So then I'm going to look down in the bottom corner. My electron geometry is linear. So I'm going to record that in the table. My molecular geometry is linear. So I'm going to record that in the table. And then I'm going to go ahead and draw. So linear and linear. So then I have my central atom. And I have one bonded over here and one bonded over here. Okay. All right. So now we're still under 2 total domains. So 2 things that could be bonded to the center one. But now there's only going to be 1 that's bonded and 1 that's a lone pair. Okay, so I'm going to go up to here. I'm going to take one of these off now. Okay, so it could have 2. It has 1 bond and 1 lone pair. So then I click my lone pair. Okay, and then kind of rotate it around and see what we see. Okay. All right, and then look at its geometry. So it didn't really change its shape. So our electron geometry is linear. Our molecular geometry is linear, and I'm just getting that from down here in the corner. And then I'm going to go ahead and draw. So I have my central atom with 1 thing connected, and then I have my lone pair. Okay, we'll just draw it like that. Okay. All right, so now let's go on to the next one. So my total domains now, I have 3 that are going to be bonded to it. So 3 things are going to bond, no unshared pairs. All right, so now we're going to start getting away from the linear shape. Okay, so I'm going to take off this lone pair, and I want to have 3 that are bonded. 1, there we go. Okay, so now you're going to spin it around a little. So you can see that this is not sticking out at all. It's going to be a planar. So it's going to be flat, kind of making like a Y shape or almost like a peace sign. Okay, so if you look down in the bottom corner, my electron geometry is trigonal planar. And my molecule geometry is trigonal planar. So basically a triangle that's flat or in the plane. Okay, so then I'm going to go ahead and draw it. So I have trigonal planar, trigonal planar. I have my central atom. And I have 1 here, 1 here, and 1 here. Okay, so now this is where stuff starts to get kind of cool, how the shapes are starting to change now. So we still have 3 domains. So we have 3 things that are going to be on the central atom. 2 are going to be bonds, and 1 is going to be an unshared pair. Okay, so let's see how that changes things. So if I show the bond angles right now, you can see that those are each 120 degrees. Okay, so go ahead and label that on your notes here. So 120 degrees apart. So it makes sense, 360 degrees in a circle divided by 3. We've got our 120 degrees for each one. All right, so now we're going to see what happens. We're going to take one of these off because now we have 2 things bonded. See, now you can see it made 180 degrees in our and we're going to add a lone pair. Okay, so now we're going to go ahead and kind of move that around. Okay, so now if we look down at the bottom, our electron geometry is still trigonal planar because there's still 3 spots to put where the electrons are. So our electron geometry is still trigonal planar. But now our molecule geometry has changed to bent because it's missing its one part of its Y. Okay, so we're going to go ahead and draw that now. So we have trigonal planar, but it's missing one of its parts. So instead of being trigonal planar, now it's bent. So we have our central atom. We have one this way, and now at the top, we have our one pair of unshared electrons. Okay. All right, and then the last one in this set, the domain, now it only is going to have one bond on the central atom and 2 unshared pairs. Okay, so we're going to go back up here. We're going to take another one of these off now, so it only has one that's bonded, and we're going to add another lone pair. So 2 lone pairs. Funny looking, isn't it? All right, so it's linear basically with 2 sets of unshared pairs. So you can see the electron geometry stayed the same. Our electron geometry is still trigonal planar. And then our molecule geometry now is linear. All right, so let's go ahead and draw that one. So I have my central atom, and I have the one atom that's there, and then I have 2 pairs of unshared electrons. So you can see that when you're in a certain number of domain, so when there was 2 things that could bond to the central atom, this electron geometry stays the same. And when there was 3 that could be around the center, the electron geometry stays the same. Okay, so moving forward, as you guys work through the rest, the 4, you're going to expect these electrons to be the same, the molecule geometry to be different. And then we didn't do these ones because they're really only worthwhile to do when you can see them 3-dimensionally. But then there'll be 5 things that can bond around the center. So these are kind of exception to the rule ones, really large molecules. They can have more than 8 valence electrons around their center atom, so they're very unusual. But you should expect to see the same thing, that the electron geometry shape will be the same for all of the 5s, but the molecule will be different. And the electron will be the same for all the 6, but the molecule will be different. Okay, so you're going to work through 4, 5, and 6 for those. And then you're going to go ahead and try to answer through some of the questions. So for a given number of domains, so let's say for 6 or for 3, what is common to every molecule? So it's kind of that idea I just talked about. Okay, and then you're going to answer about the 2 different rules between molecule and electron geometry. Explain why it's important in determining the geometry to know about both the bonds and the lone pairs. So why is it important to know both of those? This question has water and methane and what someone labeled as what they thought the shape would look like. So you're going to look at the shape. So you can see the oxygen could have 1, 2, 3, 4 things around it. It's got 2 lone pairs. So is that a linear shape or is that something different? And then carbon has 1, 2, 3, 4 around it. So when there's 4 around it and no unshared pairs, is that square planar or is that something different? Okay. What's the connection between the number of electron domains and the electron geometry? So you'll just get that from the table. Number of domains, what was the electron geometry? How does it change if you replace with 1 lone pair? How does the molecular geometry change if you replace with a lone pair? Okay. All right, and then on the back, how is bent related to trigonal planar? How is bent related to tetrahedral? And how is trigonal pyramidal related to tetrahedral? Okay. Then you're not going to do anything for number 12. Eliminate number 12. Number 13, you're going to go back to your simulator under the real molecules screen, and you're just going to draw what the 3D model looks like. Okay, so if you go back, let's say, NH3 or CH4, any one of these, you're going to go up to, let's say, BeCl2. So I'm going to go back over here, and now I'm going to click down here on real molecules. I'm going to go ahead and go up here to the drop down, and I'm going to pick, say, BeCl2 or something that seems like it. So BeCl2. Oh, geez, why is this not? All right, let's cross off some of these. All right, so we're going to do, what have we got here that matches up? You're going to do CO2. I think they changed the molecules. You'll do CH4, NH3, H2O, SO2, BF3, okay. So on your paper here, you can cross off HF, you can cross off BeCl2, you can cross off H2, and CH3Br. Okay, so you can cross those ones off. So you're going to just go ahead and draw those models, and then you're going to name them. Okay, so you'll just write what the name is down here in the bottom box. Okay, and if it's a common name and you remember the common name, that's fine. You can write the common name, like H2O. If you want to write water, you can write water. If you want to write them as their formal name, dihydrogen monoxide, you can do that too. Okay? All right, so please take your time on that. Do your best. I know that it's a little bit tricky and you're kind of trying to move back and forth between the two, but it's a really good lab so you can actually see what the three-dimensional shapes look like, because it's kind of hard based on just what my drawings were. If you guys have any questions, let me know. If you do finish it, then you'll hand it in to Mr. Vance. If you don't finish it today and you need more time to finish it, that's fine. If you didn't get very far or you have questions, just drop me an email so I kind of know where everybody's at. Okay? All right, good luck. Thanks, guys.